Is it set up? Okay. So yeah, I really don't want to delay our lunch, so let's just go quickly into our set of questions. I want to start with the previous two presentations about perceptual models, and both speakers mentioned about psychophysical models and the role of machine learning. It feels to me that there is a complementary benefits when we're looking to perceptual models into the future. We want to derive even more accurate models. Both of those things could play a role in here. I just want to dig a little bit more into that to have Jona and Rafal to comment on what do you see as what we know as a perceptual psychophysical model when we're building out a deep neural network-based model to model human vision better using machine learning-based approach, but also the opposite, right? How do you see as a ML play a role in improving the model accuracy? Maybe, Jona, do you want to comment first?
Yeah, well, as I said in my talk, I think there's quite some potential in using ML for these purposes, but we're not quite at a place where these types of models are really mature, right? So we can think of these results that we are getting right now as proof of concepts. I've actually looked into similar things that Rafal was also pointing out. If you look at LPIPs, for example, and you see, does it actually reproduce certain known behaviors, right? Like the contrast sensitivity or color sensitivity. It's actually quite bad at reproducing some of these basic psychophysics. And if you think about it, that's actually not surprising because LPIPs is based on features that were trained for object recognition. And object recognition, that for that task, we want to be somewhat invariant to color, right? We want to allow some variation, some natural variations in color and still recognize the object. So we need to think about how we can sort of train these models in a way that is more consistent with psychophysics. So that I think I'm not really aware of any work that has done so really, covering all the necessary sort of psychophysics and sort of integrating this. But I think we'll get there.
Yeah, I don't think we disagree here. I think psychophysics and machine learning could be complementary, and the big problem with machine learning is obviously problem of overfitting to specific problem and problem of interpretability. And I hope psychophysics can help with at least the overfitting problem by employing some constraints that would enforce machine learning model to follow psychophysical principles and psychophysical models. So I think this I believe in the future we'll rely on both to deliver models that actually can generalize to all kinds of conditions.
Open this question to the other panelists. Patrick, I don't know if you want to comment.
Yes, I cannot resist. So I think your question is also how we can use ML to better understand human visual system.
Yeah.
That's I think key. Yeah. Okay. And I just want to mention some of the very interesting work that shows that, for instance, a visual transformer were naturally learner of visual attention process, especially human visual attention process. Some may say, oh, it's obvious because within a visual transformer we have this paper, attention is all you need, but we have to be cautious because this is one of the typical problem also of, let's say, computer vision community who are using sometimes some concept of a human visual system branding the stuff like we know deep learning or attention, which are not necessarily fitting the concept that we understand as we understand this concept in neuroscience or in psychophysics. So we have to be cautious of this shortcut. Nevertheless, it has been shown that there was something in this visual transformer, similarly to the CSF that we were mentioning with LPIPs. There's something which is related to visual attention. So we can unreveal or discover some stuff thanks to this tool. So I see the power of these tools more to understand correlation, causality that we don't necessarily see at the first place. When we do psychophysics, like we do traditionally with Rafal, we try to design our stimuli, we have usually an intensity, whatever, and we try to relate this intensity to how we perceive it. But we're going to do in 2D, sometimes in 3D, so we cannot see necessarily all this causality in very complex space. Transformer, notably, but not only, or let's say deep net, are very useful to find unseen or non-trivial relationship. Recently, 2 weeks ago, we presented a paper at Khsib based on that, and we could see that, for instance, demonstrate that VLM help us to make a noticeable, a very noticeable breakthrough compared to traditional visual attention modeling. So visual language model are really helpful to that. Nevertheless, too complex, as Jona has shown in a presentation on the gap between complexity of Gen AI these days for compression, similar for visual attention. What is interesting here is that try to understand why they work, go in their latent space, and find what are the interesting phenomena that these tools are unrevealing, and then try to design lighter models. And now we can explore better this feature space and try to model things like more on craft or the things that we are doing. So I think there is definitely, and there are more and more papers that show that, definitely a power in a machine learning approach to find to explain some of the phenomena of human visual system. This is done nowadays in also exoplanet discussion. So people are using that in machine learning to discover our universe. We should do also it for our human visual system.
Thank you. Since you touched upon complexity, I do see there's a good direction that everybody seems to be pursuing is a lightweight, low complexity model that can be more practically be used by the industry, for example. There is certain attempt that we did in the past, for example, by folding a perceptual model into more practical application like video encoding if you want to do things in the loop, right? So the order of magnitude of complexity is a lot different compared to something you want to be just compute on the entire video to generate a score offline. I want to see if you guys have any thoughts on how we can bridge the gap further, right? To like really making perceptual model usable in loop in video encoders.
Ramzi?
What? I think the one of the first challenges with these heavy models is in practice and in video codec standardization and implementation, they're not usable. So we need to find a way and to distill these heavy models into more practical. And I think that there are a few works on the CSF, and we do see benefit using these CSF into filtering some of the imperceptible signals. I think there was early signs that these CSF delivered benefit into removing signals that we don't need to compress and send. But this stayed into the stage of just modeling, and I think there is more into. There are a few attempts in. I think it was in HEVC by Matteo Nakari at one point to incorporate these models, but I think it's still nascent and still needs to be utilized. Especially the idea of distilling these heavy models into lightweight model and using lightweight machine learning as a tool. I think we're still in the early stages, and I think there is more into this direction of research where you use more applied models, not just unbound in terms of compute models.
Yes, so kind of maybe to complement that. So you know, you may think that, for example, you have those computer vision models like Dino, V2, V3, and so on, that trained on billions and billions of images. You may say, you know, that's enough. That's enough. You know, we train it on so much data that there's no way we can overfit them. We did actually quite extensive testing on those computer vision models, those foundation models, how they are called. And they do not behave like a human visual system at all. Like CSF, forget it about it. There's no correlation between CSF. Because why should it be so? You know, why CSF is the limitation of our visual system. Why computer vision system should mimic limitation of our vision? There are multiple ways to solve a vision problem, and you know, machines may learn to see things better than we, you know, than evolution actually allows us to learn. But what's interesting about it is that the traits that are beneficial for data efficiency, like you know, contrast masking or contrast matching, were something that those large vision models actually learned from billions of images. So it could be that, you know, when those machine learning vision models will maybe not mimic our visual system one-to-one, but in terms of efficiency of data representation, they may come very close. And that could be actually a good opportunity to use those for very efficient data encoding.
Go ahead.
Okay, so two things I want to mention. So this morning we could see the set. We get a very nice overview of the new AVT tools, followed by a nice presentation from Ryan that explains us the different gain in terms of BD, whatever. But we are still operating for this decision on the red distortion, 2 dimension, and I believe this is something that doesn't necessarily shed the light where we should go, right? And I'm kind of hoping something different, because standardization body, whatever it is, or AOM, industry has also a responsibility to drive the work towards somewhere, right? I'm glad to see that within VKEG now they are considering complexity and the way how to measure complexity in all this evolution of technology. So should we take any decision based on red distortion or BD gain, or should we operate in a 3D space, red distortion complexity, or even a 4th dimension space like the one we defined it with Yanni, red distortion complexity popularity of content. So these are dimensions that we should consider, because chasing for the best BD rate these days, I think it's a trap, because the gains that we obtain, even if we get 30%, 40%, in terms of quantity of bits, they are very marginal. So we should change the game we take decisions. We should change the rule we take decisions in the development of codec. Probably it's time to go also for some kind of retrofitting. Ramzi, you can maybe say something about that, but still MPEG-2 is in use in industry. Still AVC is in use in industry. And maybe we optimizing this type of technology. It's already where we can get a lot of gain in terms of bitrate, and without sacrificing the quality, and with very reasonable complexity. So that's something I want really to highlight. And the second thing I want to say, yes, we are now in research mostly dominated by data-driven model, to the point that we can say, okay, the model is the data, okay, with all the drawbacks that we can find, but it's the dominating world where we are now, till the point that we are reaching, I don't know where we are going, but 30K plus submission to AAAI, to a conference like ICASP, 13K plus submission, but just playing with all this backbone provided by, mostly by industry, who have access to many data, who have access to computational power, and provide, thank you very much, open source model to play around with these data-driven models. The question is, where is signal processing here? And on top of that, where is human visual and psychophysics there? Rafal told us that it took him sometimes in the 2K to recover, to explain what is perceptual, and you explain, oh, I'm used psychophysics. I have to coin the psychophysics. We spent, the two of us, from when we were little kids, doing our PhD student in the community, electronic imaging and human vision. Human vision and electronic imaging, trying to reconcile perception with signal processing. And now it's even more difficult because we need to reconcile signal processing with computer vision. So now your question is that, we can reconcile that with psychophysics. And I tell you, for me, it's a nightmare. When I'm asking because we are in AOM, from the industry, especially in that field, is help us in research community to bring back some, let's say, meaningful problem that, because if you are not using the VIT, the more complex data-driven model these days, you are almost killed. I'm not sure which paper will be accepted in ICASP, which are still talking about the fundamental of signal processing. I'm not sure about that. If we are working on retrofitting, using less complex things, how it's going to be accepted in a conference? So I'm asking the industry to put this on the table in research academy. If you don't say, okay, we have important problem to work on that. If we say we value that because it's important for sustainability or whatever, there is a risk that the research will be, let's say, a bit dry. It will be, once again, only dominated by this data-driven model.
Thanks. There's a lot for us to digest, I guess.
Yes.
Yeah.
So one comment, which is funny enough, is you won't believe it that the industry is still optimizing AVC. AVC was out in 2003, 4, and we're still, not just us, everyone on the industry is still optimizing for AVC. So I am 100% aligned with Patrick on the idea that there is research in this retrofitting. The problem is, I don't think the problem is in industry. The problem, I think, is in academia, because if I publish a paper on how to optimize AVC, I'll look like really outdated. But the reality is, believe it or not, AVC is one of the biggest used codec nowadays. So there is a complete disconnect about reality, what's being used, and every single 1% you reduce on AVCs actually helps the CDN, helps encoder vendor. So it's a very extremely relevant 1%. I think that 1% won't fly in an academic paper, but that's extremely relevant. I think there is a complete disconnect between what's relevant and what makes it into the conference.
Zay, if I may, sorry again.
Yes.
Live interruption here, Yanis Katsavunidis from Meta. So, thank you, Patrick, for elevating. And I'm wearing now my IEEE Signal Processing Society hat. I'm very pleased to say that the industry board that I'm a member of has actually been tasked to do exactly what was asked, right? What problems are so relevant to industry that they deserve, let's say, their own track, session, for even a dedicated conference, actually, at that level by the society. I cannot speak for other societies within IEEE, but I can guarantee you that the energy component, let's say, I'll put it generically, in quality metrics, in codecs, in all signal processing algorithms, is now a first-class citizen. And this, I hope, will shine by the time for the next flagship conferences of the society. And I believe this community, and we know that IEEE is signal processing is a co-sponsor, technical co-sponsor of QoMEX, I think already knows about it. So I think that at least we are preaching to the choir here, except the message needs to go further, in particular in the pure, let's say, hardcore ML community, where the concept of even measuring energy is a little bit foreign. So therefore, I think I hope this will become a spike that will propagate to all the scientific fronts and make sure that at a minimum, I cannot speak for other things, we're still collecting feedback. And please talk to me if you have ideas on what else needs to be studied, except for bits and bit rate and other things, right? But for sure, I'm happy to hear from the panelists, and I think most people here, that energy is not just one more, it's a first-class citizen that needs to be taken into account very seriously. Thank you. Z, back to you.
Yeah, this feels like really concrete action items that we could be able to take is to give that feedback, right? So what we as the industry feel like, because there's so many conferences, I've gone to some of the conferences, I do feel there is certain closed society that's being inventing some of the metrics, but somehow we want them to tie to the more practical, just consider from more practical aspect. I think coming up with a list may be something we could do. Energy consumption, computational complexity, that would be absolutely on the top of the list, but we can brainstorm to bring out any other aspect as well. Slightly changing gear, I cannot resist to ask Ramzi this question. What is your 5 tech images about? Can you share with us a little bit more on that?
I have 2 with my previous company, which is Cisco Scientific Atlanta. I think in 2010 and 2012, one is for ad insertion for cable. Second one, Cloud DVR. Yeah, that what at one point was something high tech. And I have 3 with AWS Elemental. The last one is the dearest to my heart, is the one AI optimization for live encoding. And the other one was around distribution. And the third one, I need to check the notes.
Oh my God. You don't even remember. Okay.
Is one of them tied to QVBR?
Yes, one of them is tied to QVBR. Yeah, so one of them is this quality defined video bitrate. And so now you know.
Yeah, thanks for satisfying my curiosity.
And I don't know if I can add the AV1 to the list. I don't know. It's a far stretch.
We have Jona. Please go ahead with your question.
Yeah, I just wanted to respond to that discussion about complexity, right? It's not like there is no one in the ML community thinking about complexity. I mean, what I just presented earlier is exactly that kind of model that I'm excited about, because it enables us to do much lower complexity decoding than any of the other neural methods that were there before, right? And so I think there is some work coming up. I mean, this is a field that needs to, we're gonna sort of converge at some point, but people are coming from different directions. And I'm also tired of, the types of ML-based compressors that just pile layers and layers of transformers on top of each other, right? So we want to get away from that because it's arbitrary. It doesn't really make a contribution. And so as part of that, we've also started changing the incentives for our challenge, the Click Challenge, this year. So we've introduced a CPU track, for example, specifically because we don't want to assume that people have access to a GPU. So there's going to be a different track that's just for CPU. And then we're also slowly starting to sort of turn up the crank in terms of penalizing complex models. So I don't think we want to do that very abruptly, but we're definitely moving in that direction.
If I may add, also, since I'm on the Click Challenge, I think also the bit rates that were chosen, I think there is a lot of thoughts put in those, and these bit rates are practical. And I think kudos to the organizers and to putting, designing a challenge that is aligns with the practical. CPU definitely it was something that puts the emphasis on innovation with the complexity as a dimension. I think the bit rate that was chosen, I think, shows that there are voices of reason in this complexity world we live in. So kudos to the Click Challenge. It's not because I'm part of it, but I think it needs to be mentioned.
Thank you.
It's meant as a, Click is meant as a sort of a motivator for people to develop into the right direction. So we need to adapt it to what's, where the field is and where it's going, right? So it needs to constantly evolve.
Yeah, just don't get, of course, it's good that we have all this initiative. Click will be as part of PCS. PCS is not ranked A or B in some of the rankings, and that I see a big risk here that there is a discrepancies between those who think that to do research you need to do PyTorch, TensorFlow, and good GitHub and access to data, and those who are trying to work on signal processing or perception like Rafal, Jona, what you show, where you reconcile everything together. What I see is that we are a community which is dying gently because we are forming bench of students who have no clue about neither psychophysics, neither signal processing. And I can see even in company and industry, and that's a challenge for you, a kind of generation gap emphasized by the speed of the progress in CV and all the gate. Every couple of weeks we have a new model, so it's really a tsunami of things that are happening here, where the young generation may think that they can solve any problem with these things. While there are a lot of, if you put a little bit of good sense, common sense of signal processing there, you can optimize things, make things much less complex. And I can see that happening in many industries, not only in our field, a gap between experts from older generation and young generation. I can quote, this is happening also in the lab. I can quote Jeko from a very wise fellow of our community from USC San Diego. He said he's just refusing to touch these things nowadays because I cannot speak with the students. And it's one position, but we need to find a way to better reconcile everybody together. And now we can put signal processing or psychophysics in the game. Ramzi, I remember you explained me that one of your fellows want to do an equivalent of a Sobel filter with I don't know how many billion of parameters, which is just a couple of equations, right? So yeah, and that's the things that we need to be very cautious of.
Jona raised.
I will let. Do you want to respond, or I will let?
No, Jona raised her hand.
Just to.
Yes.
Sorry, please.
Oh.
Go ahead.
I just wanted to respond to that. So I do think that I personally think that there is a place for both signal processing and machine learning, but it is easy to think that signal processing, it's useless, and we've all sort of, I see that in students sometimes. You ask them to solve a quadratic optimization problem, they go and train a transformer, right?
Yeah.
If you look a bit more closely, there's a lot of signal processing that pops up in all kinds of places in ML, right? So just at last PCS, I think Taiwan, we actually got a best paper award for a paper that actually does exactly that. It builds an entropy model for a learned compressor with signal processing principles. So it's using a Fourier series to build that, right? And that's the kind of thing. I mean, I'm also I have my roots in signal processing, so I also like seeing this kind of content. But it's up to us to actually sit down, think about both problems, right? Think about both fields and identify the places where both things can be useful.
Just wanted to mention, kind of as counter-argument, is that if you think about it, the biggest breakthroughs in machine learning came from scaling things up, like AlexNet, like how to train so many layers, transformer, how to run training in parallel on, it's just, we need both, we need both people who work on this very large-scale problems, but also people who can actually make it a viable product.
I think the discussion can going on and on, but we're really, really running very, very late. I don't want to eat into people's lunchtime. Let's do this one last. I want to go around the panelists to ask the main question for this panel is really on what do you believe are the important questions to be addressed in this space. Like we're talking about signal processing, machine learning, but from the application side is about compression, right, for media delivery, for QoE. What do you feel is the important question that would have a long-lasting impact on the industry? Maybe we can start with Rafal. Do you want to go first?
Sure. I think we haven't talked much about compression for interactive content, like gaming, which can produce all sorts of different data, not only just frames, but also remote operation. It's something that people don't consider, which I believe will be very important. So how to kind of teleport somebody in another place and transfer not only just a 2D image, but maybe 3D data. So I think we need a bit more work and focus on those problems.
Ramzi?
I think with the AV2 almost out of the door, there are a lot of questions in the industry and the academia about are we saturating this model of hybrid block-based? And I think no. I think we're still using the same models of quantization since almost 4 years. And I think to me now is a challenge of innovation. We cannot add more intra modes. We need to or intra angles. Now I don't know. I lost count. We were over 100. I think there is a challenge of innovation that the codec researcher need to take on that challenge. And we're not, like quantization, we barely changed quantization. Like the changes in quantization is barely between MPEG-1 or MPEG-2 and AV2. I think there is room for to challenge the status quo, to challenge what's being established as the de facto doing stuff. I think, so my answer, we're not saturated. I think when you think we're saturated, it's where the innovation starts.
Patrick?
Two things. Beyond what we have said and the importance of reconciling a lot of disciplines together, because this is where we can do actually under constraint we innovate. So one thing, maybe we are mostly bounded, I think, in this field of compression by the component, the IC. And I'm wondering what will be the good representation of information for, let's say, the next generation of breakthrough of a way to compute. Is it quantum? Is it neuromorphic? I'm kind of fascinating also by DNA storage, where you have a forever storage capability, but you may wonder where is the decoder in 2000 years from now. So this is where maybe implicit neural representation can be useful, because people will be able to decode these contents that are here for forever, similar to the Rosa, how do you say, la pierre de Rosas? Rosa stone that was helping to understand the hieroglyph from the Egyptians. So imagine 2000 years from now, you get access from this DNA storage and want to know, oh, what is there, and how do I know there is a code there? Yes, that's one thing which is interesting to me. And another thing, I think that we can enter into the age of media or information representation that is really inclusive. So what fits the message, and what, especially when it comes to emotion. So these days we have a lot of meta-humans and everything. Can we make something more inclusive in the way we represent the information for people with some disability? And I'm kind of interested by this concept of emotion fidelity. So can I narrow down the emotion or emphasize the emotion for some people? So something like that like how we handle this type of concept. So it's not about CSF, it's not about contrast, it's not about color, it's more about higher level of perception. And can we go into this era of inclusive media for transmission of the information?
Would that have a tie to accessibility of media?
Somehow it's related to that, but also how you make sure that the message is properly conveyed and in a way that it doesn't shock, or it has sufficient enhancement for to be emotionally perceived as it should be.
Thank you.
That's,
Jona, you have the mic.
Yeah, I think, the job of academia is to explore, right? And so this is kind of where I see my personal motivation. I want to explore what is possible with these types of machine learning, with these types of compression models, with these types of tools that we can use to model humans and perception in all kinds of ways, right? I will, so that's what I will be doing, and I will hope that that will lead to some interesting models that will be picked up. And we need, as a community, we need to kind of both explore, and then also, once we know about these things, we need to figure out how to integrate them together and how to make them practical. So I think that's where I see my next couple of years.
Thank you.